Hi all, Coop here, and this is video part 2 of the parent-child series. In this video we're going to have a look at the differences between relative and world positioning of child objects, so local position and world position. I'm not going to cover the functions behind it too heavily, like how to move objects around or rotate them or scale them, but it is pretty safe to assume that the theory that I'm going to show you here applies to all those things. So all the properties of the transform component generally behave the same when it comes to parent and child relationships. So I've built this cool little grid here, and I figured to make this video a bit easier, what I'm going to do is try and show you that theory visually using this little grid setup, and in the second half of this video we'll just cover the script behind it so you can have a look at a few of the different ways you can get these properties from the player or from the objects in the game world. So to explain the grid, we have some text up here just showing the selected vector on this grid. So the grid's pretty simple. It's just what is it? It's 11 units because we also have 0, so it's 1 to 5 on the x, and also minus 1 to minus 5 on the x, and the same for y. So the x-axis running here and the y-axis running here. So dead center, where the parent object, the P, is at the moment, is considered 0, 0. So anytime we select this grid, we interact with it, we're going to get its position on that grid, and this selected text will change. So if I was to select here, for example, the vector I would get would be 0 on the x-axis and 1 on the y, so this would change to 0, 1. So it's important to note this because the position we select on this grid is always going to be sort of based off that grid. So we're always going to feed a vector 2 into this system that's going to be reflected up here, and you'll see why that's important soon. We also have the parent's position in world and local. Now, I don't really need to display both of those. I have just for the sake of doing so, and it's noted in the script as well, but because the parent isn't specifically a child object of anything, can sort of be considered to be relative to the world, so it's kind of a child object of the world. So the parent's world and local positions are always generally going to be the same. Once again, I've just included it just for the sake of doing so and just to sort of show you that. And we have the same again for the child's position, also in world and local coordinates there, the x and y, and that one's going to be a bit more interesting. That's sort of where we're going to see the majority of the changes happening. And I have a couple of functions as well for interacting with the grid. I have 3 ways of interacting with it. I can left click and it will move the parent to whichever position I choose. I can right click and it will move the child's local position relative to the parent. And that's where we're sort of going to see a lot of the fun, but that position will also still be using the grid. So if I was to select 1, 1 on the grid, which would be here, it's going to use that position to move the child relative to the parent, and we'll see that happening shortly. And the third function, I can move the child relative to the world when I middle mouse click. So that's pretty straightforward. That'll just move the child to wherever I choose, and it will tell the child to ignore its relative position to the parent, and we'll see that happening. So the first function will move the parent around, and currently the child object is going to keep its position relative to the parent. So currently it is what would be 0 on the y-axis because it's on the same y position as the parent, but it's +1 on the x-axis, so it's 1 to the right of the parent. So if we move the parent, this child should always be relative to it, so its position, its local position, and its world position will always remain relative to the parent. So I'll move it up 1, and we can see that happening now. So the world and the local of the parent have updated, and so have the child. But the child is interesting, so its world position is currently correct. It's 1, 1 on the grid, but its local position is still relative to the parent. So it's still 1 on the x-axis across from the parent, but its y is still the same. It's still on the same y-axis as the parent, even though its world position shows it as 1 on the y. I hope that makes sense. So let's move the child around. More traditionally, let's move it like it was its own game object and assume it's no longer parented, it's no longer a child of the parent object, and we'll just move it down 1. So we can see here its world position now reflects that. It's now on 0y and it's now still 1 on the x, but its local position is still reflecting the difference between the parents. So it's now at -1 on the y to the parent and still x1 to the parent, which is there. So if we move the parent around now, the child is still going to ignore it, and we can see that the local position is still changing while the world position is not. So this is where things are going to get a little bit interesting. I'm going to use the second function and I'm going to tell the child to now continue being relative to the parent, but I'm going to select a position on this grid. So I'm going to select the center point of this grid, and so the vector I feed into the system is going to be 0, 0, and we're going to tell the child to use the 0, 0 as a relative position or a local position to the parent. Now, why this is a bit interesting, so if we were to move this object traditionally and just say move to 0, 0, it's going to end up in the center of this grid. But if we tell it to have a local position of 0, 0 and to be a child object of the parent, it's going to use the relative position instead. So if I select 0, 0 on the grid and use the local position, the child object is going to move to 0, 0 relative to the parent, which is dead center. And it should follow the parent around now, retaining that local position of 0, 0, even though the world position is still changing to reflect its new position. So it's complicated, sort of. Like it's actually quite simple once you sort of get your head around how it works and understand why it works the way it does, but it can seem rather confusing. The important point there is you're essentially working with two different coordinates there. One is relative to its parent object and the other one is relative to the world itself, and you can sort of see that in this case the world is the grid. The parent object and the child object have their positions relative to each other, but the child also has its position relative to the grid itself, and that's sort of the main difference in moving it around there. If I sort of tell it to go to 5, 5 on the grid, when it gets there, I could make it faster, but this is fun. You can see the numbers moving. And then we move the parent down 1, so it'll become -1, -1 on its own axis, or on its own world position. The child keeps that, so it's now still at a local position of 5, 5. It's still 5, 5 relative to the parent, but its world position is now sort of -1 on both those axes. We can do this and move it completely out of the grid because I didn't program it to stop. That's cool. Doesn't really show you anything other than just like, hey, look, it's a mistake I made. I'll just bring that back down, and we'll just send the child back down here. So I'll move it to there. So what is it now? It's going to be 3, 3 on both axes because the parent's sitting at the center. Move the parent across 1, and sort of once again, so if I was to sort of click there on the grid, if I was to tell it to use the world position, it's going to move to that, as that's 1 or 0, 1 on, no, 1, 0 on the grid on the world position. The local is currently 2 relative to the parent, but if I now select 1, 0 as the local position, it's going to move it to be relative to the parent, so the local becomes 1, 0. So the local is 1 across and 0 up or 0 down. I hope that sort of explains it, guys. It's like I said, it's not complicated, but it's also not simple. So I hope that sort of helps to illuminate the theory a little bit behind it and maybe clears up any confusion you're having. Like I said, this is adaptable to the scale and the rotation as well as the position. So scale's a little bit interesting. I might do that in a bit more detail in a later video, as the scale does impact on quite a few things. So for example, if the parent is 5 units in scale and you move the child 1 unit, that 1 unit is actually going to be relative to the parent, so it's going to end up moving 5 units instead of 1, sort of thing, depending on a few things. Rotation is a whole other beast. It's probably a series on its own. Comparing and using rotation is a fun thing, but it's important to note that these principles apply. So if your parent's rotation changes, your child's rotation or its position sort of relative to the parent is going to update as well, but it also still has its own rotation. So we're now going to have a bit of a look at the script. So if that was sufficient for you, thanks for watching. Otherwise, stick around and we'll dig into the details now. Okay, here we have the script. It's all compacted down at the moment to keep it neat and tidy, with the exception of a couple of things. We have the variables here. These are sort of the ones that are important. We have a bunch of text objects here, which I'm just using to display all the different things, and some game objects, which is just the parent and the child objects, so only two of them. And here's sort of the real important variables. So I have a move speed for moving them, don't worry too much. I have a bool, and we use that to control if we're moving in local or world space. You'll see that happening. And we have 3 vectors, which are just being used to not only move the objects, but tell the game what info to display. I have the current move position for the parent and the current move position for the child, as well as a third one that I'm just using for some text. So that's the selected vector that you saw. And that's the variables. We'll have a quick look at the start function. So in start, all we're doing is setting those 2 move positions to be the current positions of the objects, just so they don't drift off or do anything silly. They'll just stay where they are. That's just start, nothing too complex about that. In update, we have a few things going on. We'll start with the controls. So like I said, I was just controlling it using the mouse. You could probably use whatever buttons you want. I just have left mouse, right mouse, and middle mouse in each one. So the left mouse is controlling the parent object. So I just grab the mouse position as a vector 3. So you can see it there. We're grabbing the camera, the main camera, doing a screen to world point and giving it the input mouse position, saving it as a vector 3 called mouse pos. Then we're getting that position, so we're saving it as the current parent move position, and we're doing that by creating a new vector 3. Should that be vector 3? I feel like that should be vector 2. Why have I done that? I'm only giving it 2 coordinates too, so that doesn't... Let me change that. I like leaving these mistakes in because I feel it helps me get closer to you guys. We've got the vector 2, so we're creating a new vector 2 there. We're rounding it off as well just to keep things clean, and we're just giving it the mouse pos X and the mouse pos Y, which you can see there we're rounding, math F round, and nothing too complex. And then we're just setting that third vector, the display vector cell pos, to equal the vector that we just created, or the vector that we just set, sorry. We do the same for the right mouse, but this time we do the child. We're setting that move child local bool to true. Like I said, this is going to control how we're moving the object. We do the same for the next mouse button, but we just set it to true because this is the mouse button we use to move by local position. And we do pretty much the same thing. We grab the mouse position as we did above, and we set the current child move position to be a new vector 2, and we're doing the same thing. We're just rounding those 2 mouse positions, and we do the same again for the selected pos. So that just sets the child's move position, and we just set that bool here. We'll do the good stuff in a second, but it's important to note that. And we do the same for the other mouse button, the middle mouse button there. This time we set the move child local to false because we're going to use the world position when we use that button, and we do the same thing again. It just splits it up. Cool, so that's the controls. We'll have a look at the movement itself. So it's pretty straightforward. The objects are just basically saying to themselves, alright, am I at the position that is my current move position? And if they're not, then they will move to it. We do a few different things though. So we do the parent first of all. So if the parent's not at its current move to position, that current move pos, which is done like this, so we cast the parent's transform position as a vector 2. We don't need the Z pos, and we just say if it's not equal to its move position, then we move it. And we're moving it by getting its transform position and telling it to equal the vector 3 move towards function. That could probably be vector 2 as well. I don't know why I'm using all these 3s. What am I doing? I must have had 3D in mind. Who knows? So as you can see, it's not hard. I just vector 2, vector 3, cool, everything's happy. And we're just giving it the parent's transform position, and we're giving it the current move position, the current parent move position. So if you're not familiar with this function, it just takes the position to start from and the position to end at, so to speak. Usually you would use the current position, just depends what you're trying to do, and we just give it a speed value, which is just that move speed times time.delta time to smooth it out a little bit. The parent's really easy. We don't need to change a lot. We're just changing its main position in all cases, so it is as simple as that. The child's a bit different, so once again we're using that bool, the move child local. So if we want to move in local space, what we're going to do is very similar, so same sort of thing if it's not at the position we want, but we're using the local position instead. So we're using the position relative to its parent, and that's what we're checking for instead. So instead of the transform.position, we're checking the child's transform.localPosition. We're checking to see if that equals the new move position. If it does not, so if it doesn't equal, if it's not currently at that position, then we move it, and we do the same thing as above, but we're doing the child's transform local position instead. So it's position relative to the parent, once again, just to hammer that home. And we're doing the same thing. We're using the move towards function, basically just replacing the transform.position with transform local position, and everything else is pretty much the same, just using the child move position. So if we're not moving via local position though, we want to use just the standard position. So there's no fancy world position or anything like that. Dot position is the world position of that transform, or that game object. So if we're not using move child local, if we've clicked the middle mouse button, I think it was, we just do the same check. So if we say if the child's transform position does not equal the child's move position, we just move it again, and instead of using local position, we just use position, so just the world position, and that sort of gives us the behavior we were seeing. So that break up there, that if condition, just basically the main difference is we're using the local versus standard or world position, but that's what gives you that relative behavior, so whether they move relative to the parent object or whether they move relative to the world itself. Let's shrink that one down. Last one's not as important, but it has a couple of cool little things in it. Once again, you can sort of see there's a few differences going on between the local position and the positions themselves. All that's happening in here is we're just updating those text objects that I had set. So this is all the text that's down the left hand side of the game, showing you the child's position and the parent's position, etc. And it's very straightforward. We're just updating the text of those objects and creating a string here. And so you can see for the world string and the local string, we're using the different position and local positions to get the values that we want. And I'm just getting the X and Y there. You know, you can do this however you want if you happen to be following along at home. If not, you know, it's about the theory here, guys. That's what matters. So you can sort of see the main difference there. And once again, this all applies to all of the transform properties. So if you sort of think past position and local position, you know, there are like local rotations and scale and local scale. I can't remember if any of the terms change, but they're not hard to find if you sort of start typing and figure out what you want. And yeah, so a lot of the properties of the transform are going to change based on what it's relative to. So if you sort of understand the differences between its relative position, its relative rotation, its relative scale, and its world position, rotation, and scale, life will be a bit easier. All the move functions, everything else remains the same. You still control objects the same way you would. It's just sort of important to note those differences. It'll just make your life a little bit easier. So I really hope that's helped explain it, guys. If there's anything you sort of want to see covered specifically, anything you feel I've missed here, or anything I could go into detail more with, leave me a comment, let me know, send me an email, jump in Discord. I'm all over the place. Let me know, just get in contact and we'll have a chat, and hopefully I can help out in the future. I'm going to do another video as well. Moving on, I'm going to do a little drawing line video, a video on how to draw a line really easy in Unity, because I've been playing around with it and it's so simple, it's ridiculous, and I reckon you guys would like it, so I'm going to give that a bit of a shot. Stay tuned for that one. And like I said, I'm going to try and do a couple more videos to expand on the parent and child stuff, off. Scale, I think, is a big one. It's a relatively important one. Ha! Relative, look at that pun. But I think it would be good to cover that one for you guys. So, as always, thanks for watching, and a big shout out, as always, to my Patreon supporters. You guys are awesome, and thank you. I really appreciate your help and support. And to anyone that's watching on my video, watching any of my videos, please like, please subscribe, and hopefully I'll see you guys in the future. Thanks again. See ya.